Time to play the game!
Hello. In this video, I'm going to talk about a new keyword called union. Unions look a lot like structures, except that structures used to add data, one after the other. When we did a point structure earlier, as I showed you in another video, where I had two ints next to each other, this time unions will allow us to access the memory areas, but in several different ways. Again, the best way for me to explain this is to show you. So I've got a structure s_test, an int I, a char c, a float f, and a character tab square brackets 4. Let's create the union. The same way we'd create a structure. Union, let's call our union u_test, semicolon at the end. I'm going to do the same thing inside. You'll see it'll be useful. As I've told you, the difference between unions and structures is that structures add elements one after another, and the union will allow us to access the same memory area in many different ways. For example, if I use the keyword size of, which will give us the size of an element. So for example, the size of my structure s_test. Here we go, let's display it. Here, we notice my structure is 16 byte. Let's check, an int equals 4 bytes. Char is 1 byte, so that makes it 5. A float is 4 bytes, so we have 9. And a char tab square brackets 4 is 4. That makes 13 bytes, not 16. But why? It's quite simple. My compiler does some padding between my char and the float. Because in order to access memory faster, basically the compiler will position the elements at addresses that are multiples of 4. As the processor is 32 bits, it'll create access on 4. If we had 64-bit processor, it would have to create access on 8, and therefore padding on 8. I'm going to prove it to you. If I set a char xx square bracket 3 here, recompile and relaunch, still 16. Now, if I move this char and then added it below the float, well, with this, we'd get 20. Why? Simply because there's been an extra padding of 1. So in the end, my char square brackets 3, meaning that with 3 bytes, there's a padding of 4. So the size of my structure is the sum of all the elements to which we add the padding. Now, let's use union, and you'll see how it changes everything. I'm going to use my size of on my union. Here, it indicates a size of 4. Actually, it takes the size of the biggest element. An int is 4, a char is 1, a float is 4, and a char tab 4 is 4. If I replace it with a tab square brackets 10, just for fun, we'd be at 12. Once again, padding. You should Google it. I'll put it back to 4. Let me show you how it works. Let's create a new object of type union. So union u_test, which we'll call A, and indicate that if a.I equals 42, let's use bigger number than 42. How about 42, 42, 42? It'll be clearer. My idea is to first display a.I to show you its value is indeed 42, 42, 42. Here we go. Now, let's try accessing my int going through my tab and using each char from my char tab square brackets 4 as a piece of my int. Remember, one int equals 4 bytes. Normally, if I display char tab square bracket 0, tab square bracket 1, tab square bracket 2, tab square bracket 3, I should access different parts of my int. Here we go. Let's start over. I'm going to add something to separate them, to make it clearer. At least you'll see better. We can see 50, 121, 6, and 0. Those are the 4 bytes my int is made of. We could even do the math using BC. 50 remains 50, plus 121 times 256, because the first byte is multiplied by 256 to the power of 0, the second by 256 to the power of 1, the third by 256 to the power of 2, the fourth by 256 to the power of 3. So plus 6 times 256 times 256. And normally we get the value of origin. You get it. Union allows us to access a memory area in many different ways. There are many advantages to this. Up to you to figure out the rest. In the meantime, I hope you enjoy your day. We've seen about everything there was to see today.